Number 44. The rate of change of the number of bunnies B of t in a population of bunnies is directly proportional to 1000 minus B of t, where t is the time in years. At t equals 0, the population is 100. When t equals 3, the population has increased to 300. Find the population when t equals 4. Okay, to do this, we are going to have to set up a differential equation. So, it tells us that the rate of change of the number of bunnies is directly proportional to 1000 minus b of t. So, I can say that db over dt, which would be the rate of change of the bunnies, equals a proportionality constant multiplied by 1000 minus b. Okay, then what I'm going to do, I'm going to divide both sides by 1000 minus b and multiply both sides by dt. So I'll get db over 1000 minus b equals k times dt. So now if I integrate both sides, I'm going to integrate both sides. On the left, if you have db divided by a little function, like here we have 1000 minus b, this just works out to be the natural log of 1000 minus b. Just the natural log of whatever's in the denominator. And then on the right, the integral of a constant with respect to t will just be kt. And then don't forget to add your constant. So now if we want to solve for b, we can raise each side by the power of e. So e to the natural log of 1000 minus b just leaves you with 1000 minus b. And then on the right, we have e to the kt plus c. So I'm going to move this to the top here. So we have 1000 minus b on the left. And then e to the kt plus c, I can also expand that out to be e to the c times e to the kt. Because if you have things added in the exponents, it's really just multiplying with the same base. Think if you did this in reverse. So e to the c times e to the kt, if you were to combine them, it would just be e to the c plus kt. Well, I still have 1000 minus b on the left, and then e to the c is just going to be a different constant. So I'm just going to call that c again. So c times e to the kt. And then if I want to solve for b, I can just get b equals negative c e to the kt plus 1000. I did skip a step, but at that point it's just basic algebra. So b equals negative c e to the kt plus 1000. So these other things that they give us, like at t equals 0, the population is 100, so 0, 100, and at time equals 3, the population is 300. These are used to solve for the constants that we don't know. So like c is a constant we don't know, and k, we have to solve for both of those constants. So to start with, I'm going to use this first point of 0, 100. So at that time, b is equal to 100, and then it will be negative c times e to the k times 0, because time is 0, plus 1000. And so let's see, 100 equals, well, e to the 0, k times 0 is 0, e to the 0 is 1, and so this will just be negative c plus 1000. And so it looks like c is just going to be equal to 900. So we figured out that c is 900. I'm going to erase this so I have a little bit more room to work. And now we can use our other point to find out what k is. So using 3, 300, population is 300, equals negative 900 e to the k times 3 plus 1000. And now we can solve for k. So we subtract both sides by 1000. 300 minus 1000 is just negative 700. And then if we divide both sides by 900, let's see, negative 700 divided by negative 900, that's just going to be 7/9. Dang, my pen. 7/9 equals e to the 3k. So then we can take the natural log of both sides. So natural log of 7/9 equals 3k. And then to find k, just divide both sides by 3. So k equals the natural log of 7/9 all divided by 3. So let's see what this comes out to be equal to. So natural log of 7/9 divided by 3. So it's going to be negative 0.083771. So I'm just going to write that over here. K equals negative, that's not where negative goes. Negative 0.083771. All right, I'm going to erase some of this work so I have more space. So now we're ready. We have our full equation. So our equation is just b equals negative 900 times e to the negative 0.083771 times t plus 1,000. So just where we had c, I plugged in c as 900, and where we had k, I plugged in our value for k. And now we're ready. Now we just have to plug in time equals 4 to find the population when t equals 4. So if I go to the calculator one more time, we have negative 900 plus e, that's the wrong e, e to the negative 0.083771 times 4 plus, wait, I think I messed up the equation. Sorry, negative 900 times that. There we go. And then in the end, we just add 1,000. So hopefully this gives us a positive number because we're looking for population. And it does. So it looks like our population at time equals 4 is just going to be 356. And that is answer choice A. Alright, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.